is a competitive examination taken by over a million students every year in India. There is a question from the Computer Science Information Technology branch. There is a question on the theory of computation. Here is the problem. Theory of computation, paper 1, Computer Science Information Technology, GATE 2016, question 43. It's a multiple choice question involving push-down automata. This is a multiple choice question. There are 4 choices. 3 choices are wrong, 1 choice is correct. We have to guess the correct choice. Here is the problem, question 43. Consider the transition diagram of the push-down automata given below. Here is the transition diagram below. Input alphabet sigma is AB. Stack alphabet gamma is XZ. Capital X, capital Z. Z is the initial stack symbol. L is the language accepted by the push-down automata. We are not told where to consider the push-down automata by final state of an empty stack. But normally, we take final state as standard. If we look at the transition diagram, this state and this state are final. So we assume we are considering the push-down automata and what it accepts by final state. Now we have 4 choices, A, B, C, D. 1 of them is true, 3 of them are false. We have to guess the right choice. Let us study the transition diagram of the push-down automata. In the starting state, we find the final state, where epsilon is accepted by the push-down automata. Also, we find, for example, any number of A's. The push-down automata remains the final state. So the push-down automata accepts 0 or more A's, whatever may be the stack context. Now we find, for example, on input B, it has a transition to the state. For every A which is stacked over here, B is going to be unstacked over here. At the end, we find the stack becomes empty. Now, and by epsilon move, the stack, the symbol Z is removed, stack becomes empty. Let us consider each one of the choices. We'll examine each choice and eliminate the bad choices. Then if we eliminate the bad choice, what is left is the right choice. Consider choice C. L is not accepted by any Turing machine that falls on every input. A Turing machine that falls on all inputs is called a recursive set. That's what it accepts. If L is accepted by some Turing machine that falls on all inputs, L is called a recursive set. So we have to find out about L. Now we know that the class of push-down automata generate exactly the context-free languages. We are given a push-down automata. The given language L is a context-free language. Every context-free language automatically a recursive set. And a membership problem is decidable, say, by the Semantic algorithm. The choice C gives us L is a context-free language, so it's a recursive set. It's accepted by a Turing machine that falls on every input. This not should not be there. So C can be ruled out as being in the answer. It's not a valid answer. You eliminate choice C. Let us come to choice A. L is A to the n, B to the n, equal number of A's and B's. A comes first, B comes next. Now this particular language, A and Bn, is a standard context-free language that is not accepted by any finite automata. If I don't consider this L, this is a true statement. But how about L? The language accepted by this push-down automata. Is it A and Bn? Let us consider the push-down automata. Consider the string A. Just the string A is accepted by the push-down automata. But A is not in this language. Whenever A comes, a B must come. So choice A can be eliminated. A cannot be the answer. We are left with choices B and D. If we examine the push-down automata, we see deterministic. Let's go back to the push-down automata and show there is no non-determinism or choice in any move or state. In this state, on input A comes here, A on Z, A on X, there is no choice. B on X, there is no choice. In this state, B on X, there is no choice. epsilon and z in this state, no choice. The push-down automata is very much a deterministic push-down automata. So what we have is deterministic push-down automata. We need not worry about what it accepts. It's a deterministic push-down automata. It accepts a deterministic context-free language. The answer here is deterministic context-free language. So answer is automatically D because we have shown B and C are false choices. A is a false choice. Now we need not worry about what L is, the language accepted by the push-down automata. So automatically a DCFS, that much we know. Examiner takes care of language being exactly correct for accepted by the push-down automata. The answer therefore is D by elimination. End of the presentation. Thank you very much for your attention.